Welcome to the Earth Science Classroom. Hi everyone. We're looking at the East African Rift Valley system. We're in part 3 video, and this video we look at the eastern branch in more detail. So we're going to look at basically what it is, the different components or the sections that make up the eastern branch. We'll look at the rifting, the volcanism as a consequence of the rifting, obviously the uplift from the two main hotspots. We're going to look at the Afar triple junction, put TJ there, or the triple point, and the depression. We're going to look at the Takana depression as well. All right, and basically looking at the timeline as well, how this started to rift and progress from north to south. All right, guys, join me for the video. All right, so let's recap quickly. So here we have the East African Rift Valley, or the system, which is EARS. This is our African plates, okay, which is diverging from the Mid-Atlantic Ridge, which separates the African plate with the South American plate, and it is slowly moving in this direction. We also have right here, we have our, down here, we have our western branch, which will be a different video, all right, because there's a lot to cover. And over here, in purple, will be our eastern branch right here, okay? Right here. Now it connects up with the Red Sea divergence and the oceanic crust, basaltic seafloor spreading section, also with the Gulf of Aden right here. And it connects from the north up here in the Afar Triangle or triple point, and it goes all the way south down to the North Tanzanian divergence, basically where the rift starts to diverge and break off into various other what's called arms. So smaller sections of each branch, caused mainly by the two domes. Now the outline over here, so we have one dome right here. All right, that is our Ethiopian dome. And this is the location of the hotspot. The dome is area of uplift. And we also have right here in pencil, you can see it, outline, is the East African dome, or the Kenyan dome, okay, which again is another location for the hotspot. Now, the Tanzanian craton, which is right here in the center, right here, and a craton is a very old, very stable, hasn't changed much area of rock. So it's in the billions of years old. It's part of the shield, a small section of the shield, and is very stable and has not been broken up by any kind of divergence. It kind of like is a very solid, thick piece of crust, and the divergence kind of happens around it on the edges. And the craton can kind of like control or even manipulate how and when and where that rifting occurs around the craton, which is the Tanzanian craton right here, which sits, has Lake Victoria sitting on it as well. So we're looking at the eastern branch over here, guys. And why is it so important? Well, it's over 2,400 kilometers long, right? It starts at the Afar depression. Wait, there we go. Depression, which is all the way up here. And this is also called the triple point or triple junction, the meeting point of three plates, three tectonic plates. So we have the meeting of three plates. When I say meeting, we get the boundary or the margin. Now, in terms of tectonics, this is a divergent or a emerging an emerging divergent plate boundary. Now, it has different ages. So it has different ages, and therefore it's in different stages of rifting or development. So the African plate is kind of like this whole thing is the African plate down here. So anything south of here is the African plate. And up here we have the Arabian plate. So we have Arabian plate, and that's a minor plate based on the size. It is continental crust. And this is our African plate. Again, mostly continental, even though some of it does occur under ocean towards mid-ocean ridge, but it's generally all the African plate. Now, the cool thing is we have a divergent plate boundary right here. These three like arms, basically, these three arms that connect right here. Okay, is location of a spreading center. So this African plate is being spread or split up over a long period of time. Started between 47 to 35 million years ago with some volcanism, and then the uplift and the hotspots and the dome formation and the crustal stretching, the crustal flexure, and the brittleness of the crust causing the rifting and the tensional stresses applied to it, that you have this African plate being split into two smaller subplates called the Nubian, okay, which is where it drives from North Africa, and the Somalian plate, based on the main country that it's located on, Somalia. So in the future, 10, 15, 20 million years in the future, Africa will be divided into these two smaller subplates on its course on its course or cycle of the movement of plates around our surface of the Earth. And the Arabian plate, so the direction of movement through divergence is this, where we have the divergence like this. So the Red Sea is getting larger, Gulf of Aden's getting larger, and the Somalian plate is moving east, and Nubian plate is moving west. Now, technically, the western branch is kind of a passive rift with mostly east direction of movement or motion, but we have this separation of these three, and it's what we call the triple junction. And this kind of tensional forces applied to this area, especially where they all meet in the Afar Triangle, which is right here. Okay, put the triangle right here. Afar Triangle. It creates a very large depression, or an area that has been down thrusted through normal faults or normal dip faults. So we have normal dip, dip slip faults that create grabens, okay, and large connected basins that these all show in different stages, different widths and different lengths, but they're all kind of connected, mostly in the eastern branch, they're mostly connected in a smooth, continuous basin. So there we have it. That is the Afar triple junction with the depression, the triangle, and the three plates moving away from each other. So looking at this picture of the Afar Triangle and depression, this is a very basic diagram here where you have the Arabian Peninsula right here, you have Africa right here, and you have the kind of the Afar Depression or the Afar Triangle with a very low elevation land going down even lower to the coastline. You also have the Gulf of Aden right there. You have this small little passageway into the Red Sea. You have some kind of young oceanic crust, basaltic crust, forming here through the crustal divergence right here, and obviously some here. And what happens is there's all these faults that are created, and they kind of come together in this funnel, and they create the northern part of the main Ethiopian rift. And this is an old, very old section of rifting, very the later stage of development. And we have two plateaus on either side of the Afar Depression. Okay, you got the Somalian plateau, and you have the Ethiopian plateau. Okay, so that's in general, and then we're going to add more details in 1 second. So this is a quick little summary in terms of the countries that are involved or located on, around, or in the Afar Triangle or Triple Point. You have Ethiopia right there, Ethiopia right here. You have Eritrea right here, this small country right here, which kind of like goes basically from the highlands down to the depression. The Red Sea, as I mentioned before, the Gulf of Aden before. You have Yemen, which is part of the Arabian Peninsula, Yemen right here. And Oman, which is up here on the top northeast area. Then we have Sudan. Oh, sorry, Somalia, not Sudan. Sudan's further down. Somalia, right here. Okay, and you also have a country which is a really cool name, Djibouti. So I always like to add in, some geography into this because obviously we need to know where these places are. It's tough to also visualize the places just on physical landforms or geomorphology, but to know the political country borders and what countries are around there and what seas or oceans, it makes it easier for the students to relate where this thing is, especially if you're not from this area. That makes it why I do this. So here we have a picture of a more detailed area. So what we're looking at here, we got the same kind of, these are the kind of ridges, the kind of like border. Oh, can't spell border. The border, the depression. So these are higher elevation. So the plateaus, Ethiopian over here, and Somalian over here. Somalian is kind of more. Somalian has more erosion and is generally lower in elevation, whereas the Ethiopian highlands can be as much as 3,300 meters up, but over 2,000 meters average. So you have this higher plateau on the western side. Now, these little dots are showing the direction of the graben and the rifting. So it's going this direction. These little triangles that I've drawn in here, these are locations of volcanoes and some magmatism. And this whole area was covered in flood basalts. So as this triangle, this depression was forming, and the two uplifts were happening with the domes. You have the Ethiopian dome, which this is all a part of. So the Ethiopian dome that contains both plateaus, pushing it up from the hotspot underneath. You have this because of that, you have this spreading center right here, and the triangle. All three plates are spreading away from each other, and you get this very stretched part of the crust, making it very, very thin and low elevation, and that would also either cause volcanism, or volcanism also happens prior to the uplift as like a precursor to uplifting, where the volcanism for the top of the plume head is released, and this flood basalt goes all over, pretty much all over this area. So this is all flood basalts from two main parts. Now this part in the triangle is more recent in terms of the time it was, and it was the Neogene, which was around between 23 million to about 2.6 million years ago. And then further down in the Ethiopian rift, down here, you have older flood basalts from an older part of the rift, which dates back to around 33.9 to 23 million years ago, and that was Ologene epoch kind of flood basalts that kind of filled the ancient Ethiopian rift down here in the more southern area that connects into the Afar Triangle right here. So all these pencil marks right here are drawn, and that the red dots, that's your actual divergence. That's where the plates are diverging, the spreading center, and around the spreading center, the plate boundary, you have all these normal faults. Okay, all the normal faults which are caused through tensional forces applied to the crust, where the crust is being stretched, and normal faults occur where the crust is brittle and fractures occur, and it's being sliding down, and you get basically large scale subsidence and downfaulting. And that can also cause the release of magmatic material and large volumes of basaltic flood magma going all over the area, and also help to create the plateaus as well. So going back to, we looked at the Afar Junction and the Afar Triangle, which was this area here that was shown in the last map. So we kind of looked at that in more detail, depression, the low areas, the plateaus, and it's all a part of this large Ethiopian dome, which is caused by the uplift from the different two mantle plumes that come from the core mantle boundary. And it's causing the rifting. So the red line's rifting. So here is our eastern branch right here. All right, down to the North Tanzanian divergence up here. Now, the timeline was, some research is showing that volcanism and flood basalts came as early as 47 million years ago. And then you have the uplift from the hotspot and the plume pushing up the crust lithosphere into two different domes or distinct domes around the cratons, which was the Ethiopian dome and the East African dome. And that directed the rifting, which occurred from north to south. So the northern part is the oldest part of the rifting, more developed stage, more wider, deeper, more distinct gravens and basins and connected basins, whereas the western branch over here is definitely less continuous, not as well developed. The eastern side is also very large for volcanism and large volumes of volcanism and lots of shield volcanoes, some stratovolcanoes, some complex, and also some massifs. So massifs basically are volcanoes that are created through faulting, an exposure of a peak through faulting, as opposed to other ways of creating volcanoes or orogeny. Massifs are like just a section formed from faulting. And we have some classic volcanoes on the eastern side, one up here, Mount Kenya, up there, another volcano up here as well, and down here is Mount Kilimanjaro, all right, which is the classic snow-capped, beautiful peak, towering over, northern Tanzania and Kenya, and the safaris and the Serengeti, and it's made up of three distinct peaks, three distinct craters, and was active about 1 million years ago. I'm going to do a video just on those two volcanoes and some shield volcanoes in the eastern branch because it's really interesting. And I'm going to do a video on just the Great Lakes as well. Okay, that's also a very interesting part of the Rift Valley system, of these very deep, very, very deep lakes. So the eastern branch starts off in the north with older lifting, older rifting, and then as it goes further south through the eastern branch, they get younger and younger up until about 15 to 18 million years ago down here towards northern Tanzania. It does break off into the southeastern branch, and there's a southwestern branch down here. They are scattered, less developed rifting, but they are part of the whole system. It goes down to basically Mozambique down here in the south and far north as Jordan in the Middle East. So this is a very extensive, over 6,000 kilometer rift on the continent, which is actively pulling apart the crust. So in terms of elevation, you've got about 150 meters and below down to the sea, the coastline for the Afar Depression. You have the highlands, which are in excess of 2,000 meters and 1,100 meters either side for Somali and Ethiopian highlands plateaus. Then you've got the cool area of the Turkana, Turkana Depression, or the Turkana Lows. Now it goes down to around 600 meters in elevation, which obviously is much lower than the plateaus. There's a little section now. Research has shown that this is kind of like a failed rift, part of ears, and didn't really work out. Basically, because of the two domes. It's kind of in between the Ethiopian dome and the East African dome, and really kind of lowers down. But there is one lake in the depression, which is the only real lake in the eastern branch, which is Lake Turkana, which you see right there outlined in blue. And then it comes down, goes back up in elevation over the East African dome, over that next hotspot, that uplift area. Kind of continues eastward, east side of Lake Victoria, which is this large lake outlined in blue in the center right here. You have these connected areas of rifting and grabens and developed elongated basins right here. And you have the two classic volcanoes in Kenya and Mount Kilimanjaro over here on the eastern side, here on the rift, the ridge rift, basically. So you've got the different elevations. You've got the Turkana Depression and these two sections also connecting the Afar Junction with this triple point and divergence of the three plates, which is awesome. And I'll get on to talk about the western branch next, the Great Lakes, and also the two volcanoes mentioned today. Guys, I hope you enjoyed this video. I hope you get an idea of the East African Rift Valley as a great case study, but not only flood basalts, not only human ancestry and finding early hominins and skeletons of early humans, to the different lakes, Rift Valley basins, the grabens and divergence, and we can actually see this happening in our lifetime. See it diverging, see the continent split apart into the Nubian and Somalian subplates, and really examine what's happening in detail. So we can use that as a way to examine how Pangaea broke up, or previous supercontinents like Rodinia, how they broke up and formed current continents as they are today, and what happened in the future as well when they collide. All right, guys, thanks a lot.